In this video, what we're going to look at right now are graphs of trig functions. So far, all we've really talked about with trig functions is a unit circle and getting values from the unit circle. We're going to add a more visual component here where we're going to graph these functions as y versus x. So what we're going to graph mainly will be things like y equals sine x, y equals cosine x. In later classes, we'll talk about the graphs of our other functions, including tangent, cotangent, and secant and cosecant. So, right here is a little visual kind of explaining what's going on. The idea of this, if I want to create the graph of the sine function, what I'm going to do is think about all the values I already know for the sine of x, or the sine of theta, is what we've mainly talked about. So, if I do this, I know various points around the unit circle. I know my quadrantal angles, and I know 3 points within each quadrant. Like I know that the sine of pi over 6, 30 degrees, is 1/2. I know that the sine of pi over 4, 45 degrees, is square root of 2 over 2. The sine of pi over 3, or 60 degrees, is square root of 3 over 2. And the sine of pi over 2, 90 degrees, is 1. So I'm going to take these ideas to construct a graph. I could use all of these points, but really we're going to make this a bit simpler. To create the graphs of our trig functions, mainly what we will focus on are our quadrantal angles. That won't be true for every one of these, but for the most part this is something that we can say. So for our sine and cosine, we're going to be looking really at just our quadrantal angles. So if I think about moving around my unit circle, I want to think about what happens for 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and then when I make a full circle and come back to 2 pi. So if I think about my points around the unit circle, I know that my sine is the y coordinate of these respective points. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. If I make a full circle, I get that the sine of 2 pi is again 0. So here's how I'm going to construct this graph. Okay, pretty typically you will have to place a scale on your graph, both on the y-axis and along the x-axis. I'm not aiming to keep this super accurate like we see here. This is 1 and this is pi. Pi is significantly larger than 1, but I didn't really force that into my scale. What I am trying to do, though, is keep this as a scale and space these things out approximately evenly to get a good-looking graph. I want to take these points, plot them over here to create a sine function. So we said that the sine of 0 was 0. The sine of pi over 2 is 1. The sine of pi is once again 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is again 0. So what I get is a curve that looks something like this. Now be careful when you're doing this. You really don't want this to be jagged. It's a nice, smooth, rounded curve that goes up high, rounds off, comes down low, rounds off. But what I will see here is that it's only going between its largest value 1, its smallest value negative 1. This should make sense if we think about going around the unit circle, and the largest values of sine and then later on cosine will be the largest value is 1, while the smallest value is negative 1. In fact, all of our sine values must be between those two things. My graph reflects that. Okay. So when I created this graph, I placed a line here indicating that I would not go above 1, and I placed a line down here indicating that I would not go below negative 1. I would then divide this up to place these 4 equally marked intervals, each in this case of pi over 2. So I have pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi. So that gives me this graph. Now, for the questions we typically like to ask, a typical question for functions is domain and range. Well, we just discussed the range. The smallest that the sine can ever get is -1. The largest it can get is +1. Okay? Our domain, well, here's the thing. What we have graphed is simply 0 to 2 pi. However, we've talked about the idea of coterminal angles. We know that 0 radians and 2 pi radians are in effect the same angle. I could keep going in this fashion. I could add on or take away full revolutions, either clockwise or counterclockwise. So 0 and 2 pi are the same, -2 pi or -4 pi or +4 pi or 6 pi or 8 pi. All of those are coterminal angles. This graph will continue on because these new angles just allow me to circle around the unit circle repeatedly. My domain is going to be all real numbers, -infinity to infinity. Okay? But the other point I was making right there is I start off at 0, and the sine of 0 is 0. Now, as I move along the unit circle, the sine starts to increase fairly fast, slows down a little bit as I approach 1, and then starts to decrease a bit faster. That slows down, it starts to level off down here. And then I make a full circle at 2 pi. What would happen after 2 pi? Well, if I come around and make a full 2 pi, I start getting into, next up would be 13 pi over 6, or 9 pi over 4, or 7 pi over 3. What I would get is just a repetition of this. So what I'm going to see is a graph that just extends and repeats the pattern I've already sketched. Okay? So it would keep going on in this fashion. Forgive me, that's a bit of a messy little sketch right there. It would just keep going on in the fashion that I've already created. Okay? My domain is all real numbers, but we're introducing a new concept here called period. This function is what we call periodic. It repeats itself every so often. As I go around, I go through the unit circle once, and if I go past 2 pi, I just start encountering the same values once again. Similarly, if I went in the negative direction, I would see the same thing. Just keep going through the same values. So this is a periodic function. Its period, well, that corresponds to going once around my unit circle. So the period of sine is 2 pi. Now what if I did this with cosine? How will cosine look different? Well, again, if I want to construct this graph, I can start off by dividing my axis. Again, 4 approximately equally spaced markers here, pi over 2, pi, 3 pi over 2, and 2 pi. The smallest that cosine will go is -1, the largest it will go is +1. But as I go around the unit circle, I'm now looking at the x values, not the y values. I start here, the cosine of 0 is 1. For pi over 2, I'll have 0. At pi, I'll have -1. At 3 pi over 2, I'll have 0. And at 2 pi, I will once again have 1. So I want to plot those points over here. 0, 1. Pi over 2, 0. Pi, -1. 3 pi over 2, 0. 2 pi, 1. So what do I see here? Again, a nice smooth wave curve goes like this. Okay. Now at first, this looks fairly different from our sine curve, but as we study this more, we'll see that really all I'm looking at here is the same curve, just in a slightly different place. If I continued this on, I know it's going to repeat. Again, like I said, it is a periodic function, so the rest of it will look something like this. Over here I'll come down, and I can see that these graphs are actually pretty similar. The way we will look at it, though, our sine kind of starts at 0 and then begins to increase. Sorry. Our sine starts at 0 and begins to increase, while our cosine will start at 1 and at first decreases, moving down through 0 and -1, before it starts to increase again. Okay. Let's take a look at the domain, the range, and the period. So again, cosine, just like sine, I can keep going. I can take negative angles, positive angles that are coterminal with whatever. I will always be able to evaluate the cosine, just as I did with sine. My range, well, the smallest value that cosine can take, just as sine did, is -1. The largest it can get is 1. Sine and cosine will take on all the same values, just not exactly starting in the same place. The period, again, as I go around the unit circle once, I will go through all the same values, and then I will start to repeat. So I have a period of 2 pi. Again, this idea of a function that is periodic, as time goes by, as x or theta, however we're envisioning it, increases, I will just start to repeat the same values that I've already graphed. So what I see is a periodic function. So each of these, what I started off with, going from 0 to 2 pi, is just one period, a single period of the function. In that period, I see everything the function ever does. It hits 0 and goes up, comes down, goes into the negatives, and then once again it hits 0. For the cosine, I started up high, I went down towards 0 and then into the negatives, back up towards 0 until I hit 1, and the cycle starts again. This idea is very powerful. Okay? Sine and cosine are functions that have a period of 2 pi. If I were to extend the graph beyond my single period from 0 to 2 pi, I would see a repetition of what I have already graphed. The graph would just repeat. What I've sketched up here, you see an example of, this is our basic sine curve, starting at 0, increasing to 1 at pi over 2, to 0 at pi, to -1 at 3 pi over 2, and then back to 0 at 2 pi. Something similar over here I've graphed with cosine. My apologies, the graphs are a little bit messy. But if I were to extend and go out past 2 pi, more than one full revolution around the unit circle, I just start seeing a repeat of what I have already graphed. Okay. All right. So we see here a nice visual. This is a breakdown of what's happening in each quadrant. The sign in the first quadrant is positive. It's also positive in the second quadrant. In the third quadrant, it starts to go negative until finally at 3 pi over 2 it hits -1 and starts to increase until finally it gets back to 0. Cosine, again, starts positive in the first quadrant. In the second quadrant, my x-coordinates are negative, so I start seeing negative cosine values. And then I start to increase again in the third quadrant until finally at 3 pi over 2 the cosine is 0. I increase again. So these graphs are what we would call waves. These are wave functions. We see they are just going between the same values. They are oscillating is the word. Okay? And since they are oscillating and they're just going between a certain small set of values, we have what is called an amplitude. Okay? So an amplitude of a wave refers to the height above or below its central value. So each of these red markings I have right here is one amplitude. Okay. There's this middle line in here. Normally, as we've talked about functions going back to earlier days of algebra, we've talked about vertical shifts. Well, since this function is a wave, it will create this line right in here that the function is moving above and below, this line that it is following, or again.
Teacher interruption, students, it is now 3:05 and all buses have left for the day. If you are not with a teacher, coach, or in a supervised activity, it is now time to leave the building and head home. Have a great afternoon, Lake Friday.
Sorry about that. Announcements. It is oscillating about this central value. For sine and cosine, I am oscillating about 0, which is generally pretty typical for trig functions, although it gets a little bit more complicated as we move past sine and cosine. All right, so let's take a look at a transformational form of a sine. And it's written here as sine, but everything we're going to say about sine would work just as well for cosine. Up here, I know I can put a negative in front of this. If I put a negative in front, it'll be a reflection in the x-axis. And then I will have this value out here, this a. And I see some stuff in here. I see the sine of b times x minus c. This will be discussed in our next lesson. This is how the graph can be changed in the horizontal direction. And then I see this plus d. Okay? So again, this negative will reflect the graph in the x-axis. A, right there, will cause a vertical stretch or compression that will change the amplitude of our graph. So I will go higher above the midline here, more than 1, or potentially if I compress less than 1 unit, so I might only go up half of this distance. And then D over here is our vertical shift. D will shift the graph up or down, but as I shift the graph up or down, it's going to change where that baseline, that middle level of the graph is. So if I were to add, say, 5 units here, then I would be oscillating above and below 5. Let's take a look at some examples. Okay? So right here, I have f of x equals minus sine x. I've already started prepping my graph. I have a negative 1, I have positive 1 up here. I've divided the x-axis into increments of pi over 2. And what I want to do is analyze this. Well, this is not sine x, this is minus sine x. If I graph minus sine x, I want to think about my key points here. My key points are what happens as I go around the unit circle. So I will take these values right here. Well, the sine of 0 is 0. That much I know. Okay? The sine of pi over 2 is 1. Now notice up here there's a negative in front. So there is a reflection in the x-axis, which means where my sine normally starts at 0 and then goes up to 1 and then comes back down, if there's a reflection, rather than going up to 1, I'm going to go down to start. I'm going to go down to negative 1. At pi, the sine of pi is 0. Whether I negate it or not, that will still be 0. You'll have to forgive me here. I'm messing up my graph a little bit. The sine of 3 pi over 2 is normally negative 1. But when I multiply that negative out in front, again, I'm going to go up to positive 1. Finally, when I make it back around to 2 pi, the sine of 2 pi is 0. So I'll see a graph that looks like this. Okay? I can analyze it and look at all of these things. I just had minus sine x. The only transformation I see is that there is a reflection in the x-axis, which means my amplitude is 1, just as it is for a normal sine function. My period is 2 pi. There is no vertical shift. And my domain is all real numbers, negative infinity to infinity. The range, well, I reflected the graph, but that didn't change the fact that I'm going between negative 1 and positive 1. That is still my sine graph. Let's take a look at a few more examples. In problem 2, I see 2 sine x. 2 sine x. So here, there's no reflection, so I'm picturing something like a normal sine, something that will start at 0 and go up, come back down, wave in that fashion. I'm still going to pick the same points, 0 pi over 2, pi, 3 pi over 2, and then 2 pi. I'm going to divide up my axis. I'm going to try and space this out as evenly as I possibly can. So let's say that'll be 2 pi. That's about halfway. That'll be pi, about halfway between there. And I'm going to label these. Pi over 2, pi, 3 pi over 2, 2 pi. Okay. Now, there is a 2 in front of this, which means rather than sine, which normally goes between -1 and 1, I'm looking at 2 sine x, which means there is a vertical stretch. So I will go up and go down twice as far. So rather than going between 1 and -1, I will be going between 2 and -2. So I've marked this off. Notice I've placed a dashed line here. That's not by any means necessary, but it can help sometimes to really understand what this function is doing. So what I want to think about is when the sine starts off at 0, and again, I'm picturing my unit circle. At 0, the sine is 0. At pi over 2, the sine is 1. But if I double that, I don't get 1, I will get 2. As I come around to pi, the sine of pi is 0. Multiplying that by 2 still gives me 0. At 3 pi over 2, again, the sine of 3 pi over 2 is equal to 1. But what am I doing? I am actually multiplying it by 2. Excuse me, I said it's equal to 1. It's equal to -1. 2 times -1 will then give me -2. And at 2 pi, I come around, the sine of 2 pi is 0. Multiplying by 2 will still give me 0. So let's graph this. I start at 0 and I go up. Not to 1. There's a stretch here. My amplitude is now 2, so I go up to 2. At pi, I'm coming back down to 0. At 3 pi over 2, I go back down. It should be at -2. It's right there. And at 2 pi, I start to come back up to 0. And as best as I can, I've got these 5 key points right here. I'm going to go ahead and put a curve through them. Try and make it look nice. It should not be sharp in any way. You really want to give it a nice sense of just it's always kind of turning a little bit. Okay. And again, if I were to graph more over here, I would see it come up and hit 2 again and then start to go back down. And it would be repeating because it is periodic. There was no reflection. There was no vertical shift. The period was not changed. What we changed was the amplitude. The domain is the same. And the range, since I changed my amplitude, I'm not going between -1 and 1, I'm going between -2 and 2. Okay, I'm going to do a couple more examples. Let's do a cosine example. In problem 3, I'm asked to graph f of x equals -2 cosine of x. As I look at this, I can see that, yes, there is a reflection in the x-axis. I can see that the amplitude has been doubled. The amplitude is 2. We have not discussed how to change the period at this point, and there is no vertical shift to this graph. Now, based on that, I can actually answer a lot of these questions. If you think about the way the cosine behaves, you can really create the graph even without the 5 key points. Cosine, we want to start getting the image in our mind. We think about our unit circle. Cosine starts off at 1. Now, if I reflect and I multiply by 2, I'm not going to start off up here at 1. I'm not even going to start off up here at 2. I'm going to reflect and come all the way down to -2. And then as I move through, what's going to happen to the cosine? Well, I'm going to go up towards 0, toward this middle line. I'm going to go up again, 1 full amplitude above 0, up to 2. I'm going to come back down, 3 pi over 2. The -2 times the cosine of 3 pi over 2 will be 0. And at 2 pi, I will be back down at -2. And so then through these points, I put a nice smooth curve. Okay. And you can see there it's a little bit off center, and that's just kind of my fault if I didn't space this out as well as I should. This should look pretty symmetrical, and it's a little bit off, and that's just my not graphing it well enough. Those key points I used again. Once you get the hang of this, the key points, I don't know that you really need them. Not to say they aren't important, but if you get the hang of what's going on here, there's usually a way around it. So I started off not at 1, not at 2, but at -2, because I had an amplitude change, I had a vertical stretch, and I had a reflection. And I moved up to 0, moved up to +2, back down to 0, and then back all the way down. My domain is -infinity to infinity. My range is -2 to 2. Okay. So these examples are fairly simple. What we want to look at now is what happens if I start putting multiple transformations together in the same function. What if I need to vertically stretch and not just vertically stretch and reflect, but also if I have, say, a vertical stretch and a vertical shift. So, if we move ahead, if I shift something vertically, what's going to happen is, here I'm going down 2. So like in this example, normally the cosine would go between 1 and -1. If I go down 2 units, 1 goes down to -1, -1 will go down to -3. I'm going to go ahead and extend this one down. So then what I'll see is a graph that exists just between those two horizontal lines. Okay? I'll divide up my axis, pi over 2, pi, 3 pi over 2, and 2 pi. Got to make sure to label this. If you do not label this, that will not be a full, well-displayed graph. I need to see that. Okay. I'm going between -1 and -3, and I know right in here this is my center line. This is the middle. What will cosine do? Well, again, I know that cosine starts off at its largest value. There's no reflection here, so I'm going to start off up here. And what will it do? It's going to go down to 0, and it's going to go way down, then it'll come back up, and it'll come all the way up. So I get this graph right here. Nice little wave function. Looks like this. Okay. I said it went back down to 0. The cosine does go back down to 0. If I'm subtracting by 2, though, this will be -2 is this base line, this midline that I am oscillating about. So if I wanted to analyze this function right here, my amplitude is unchanged. It's 1. There's no reflection. The period is still 2 pi. For my vertical shift, I need to go down 2. My domain for all sines and cosines is all real numbers. But my range, rather than -1 to 1, since I shifted down 2, -1 moved down to -3, +1 moved down to -1. Okay. Let's look at one more example where we combine these ideas. I'm going to skip all the way to problem 7. In problem 7, I see f of x equals 1 minus 3 times the cosine of x. All right. So if you want to rewrite this with the 1 written at the end as a +1, you're welcome to. It means the same thing. There are, of course, some mathematical reasons why it might be written that way, but they're not that important to what we are doing. So let's think about how to construct this graph. I need to label my axes. Along the x-axis, my period is unchanged. It's 2 pi. I'm going to take that period, no matter what, and I'm going to divide it into fourths. So, Try and space this out evenly. Those look about evenly spaced. I'm going to label them pi over 2, pi, 3 pi over 2, and 2 pi. All right. Now, how will I label the y-axis? Well, I can see a couple things here. There's a vertical shift going up 1 unit. There's a reflection in the x-axis. And I can also see this 3, which will change my amplitude. Well, this means that I've gone up 1 unit. And from that 1 unit, I need to go up 3 units above at the height of my wave, and 3 units below at the bottom of my wave. So that's how I'm going to label the axis. There is 1, 2, 3, 4. And down here I see 0, and -1, and -2. Again, if you want to mark off the lines you're going between, or if you want to mark off the middle line, you are welcome to do some combination of those. If you don't feel the need to, that's okay too. Just make sure they should be dashed because they are not actually part of your graph. So, let's think about this. Let's not overcomplicate this. Cosine. If I'm thinking cosine, I know that cosine starts up high, then goes low, then comes back up high. If there's a reflection, it will do the opposite. It'll start down low, then go high, then go low. How low? Well, the bottom of my range. The lowest this is going to get is -2. Then it'll come up to the middle, 1. Then it'll go up to the top of the range, 4. Come back to the middle, and go back to the bottom, -2. So my graph will look like this. Now again, I can write down my key points, but it helps a lot of the time to just understand this whole idea of where am I starting, am I going up, am I going down, what values am I going between. We can simplify what we're looking at by thinking of it in those terms. My key points, if I write that out, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, I know that cosine normally starts up high, but this will start down low at 1 minus 3, or -2. At pi over 2, this will be zeroed out, so I got the 1. At pi, I will have 3 plus 1, the 4. 3 pi over 2, cosine is 0, so I get 1 again. At 2 pi, I'm back down to -2. My domain is all real numbers. My range is -2 to +4. Hope that has helped. If you have further questions, make sure you study, make sure to ask.